Alright, hopefully today's lesson is super short. No, Olivia, I am not in the bathroom. I'm at my desk in my classroom. Lesson 6.2, Bisectors of Triangles, Part 2. Use bisectors of triangles. So yesterday we did all of our circumcenter things. Now we're doing all of our incenter things. So we are finding the incenter of circles. I can inscribe a circle within a triangle. I can use points of concurrency to solve real-life problems. So an incenter, as you recall, the circumcenter was when we took all of the perpendicular bisectors and we found where they met. Now we are going to find the angle bisectors. So the angle bisectors of a triangle are also concurrent. This point of concurrency is called the incenter of the triangle. For any triangle, the incenter always lies inside the triangle, so it will always be inside. This is what it looks like. So I'm going to cut each of my angles in half and draw a line. All of those lines will connect at this point P. That is my incenter. My incenter theorem says the incenter of a triangle is equidistant from the sides of the triangle. So each of these perpendicular lines are equal. So PD is equal to PE, which is equal to PF. Cool. Using the incenter of a triangle. In the figure shown, ND, so this line here, equals 5x minus 1, and E equals 2x plus 11, and for part A, I want to find NF. So, using my incenter theorem, I know that if this is the incenter, all of these lines are equal. So first, I have to figure out what x is. So I'm going to, just writing out everything I just said. So ND equals NE, so 5x minus 1 equals 2x plus 11. I'm going to bring the 2x over here, so 5x minus 2x is going to equal 3x. I'm going to bring the 1 over here, so 11 plus 1 equals 12. 3x equals 12, so I divide by 3, and you get x equals 4. Once again, hopefully you know this. You guys are in algebra, you guys are in geometry, so hopefully your algebra is down packed. I know it might not be, so if you need help, just raise your hand now and I will pause the video and help. So step 2 is to plug in x. I can take either ND or NE, they are equal, to find out what NF is. So I'm going to go ahead and grab ND, which is 5x minus 1. I'm going to plug in 4, because that's what x equals. 5 times 4 is 20, minus 1 is 19. So, since ND equals NF, the answer to our question for what is NF is 19. In part B, it says, can NG be equal to 18? Explain your reasoning. So this line here is NG. If I know that this is 19, can this be 18? Recall that the shortest distance between a point and a line is a perpendicular segment. In this case, the perpendicular segment is NF, which has a length of 19. Therefore, because 18 is smaller than 19, NG cannot be equal to 18. So this length cannot be shorter than this length. So your answer is no, because NF is smaller than NG. Okay. Because the incenter P is equidistant from all 3 sides of a triangle, a circle shown using P as the center and the distance to one side of the triangle as the radius will just touch the other 2 sides of the triangle. The circle is said to be inscribed within the triangle. That was a lot of words to just say, if I take all of the angle bisectors and I find that perpendicular line from it, I can use the radius from my incenter to that perpendicular line, and it will make this perfect circle, and that is what we call our incenter circle, and it is inscribed within the triangle. Okay? Just a bunch of fancy words to say, here's a circle inside of the triangle. Here's our modeling real life problem. City officials want to place a lamppost near the street shown so that the lamppost is the same distance from all 3 streets. Should the lamppost be at the circumcenter or the incenter of the triangular piece of land? Explain. All right. Because this shape of land is an obtuse triangle. So you see how it's an obtuse triangle. Yesterday we learned that the circumcenter would lie outside of the triangle. It would be over here. And it would not be equidistant from the sides. It would be equidistant from the angles, so from where the streets meet. So by the incenter theorem, the incenter of a triangle is equidistant from the sides of a triangle. That's what we want. We want it the same distance from all three sides. So we're going to use that incenter. The lamppost should be at the incenter of a triangle piece of land. So it'll be like right there, and it should be the same distance from each of these. Okay? The end. I'm done. Okay, bye.